Okay.
Are we recording? Okay, 2.3, we're looking at higher degree polynomial equations. I have some issues with this unit or the way they named it. Now, first off, what we're talking about is primarily equations that are what's called quadratic in form. Remember, your general quadratic is ax squared plus bx plus c equals 0. And we can solve every single quadratic. We saw that in last unit. We came up with a quadratic formula and that'll solve every single quadratic anybody could ever dream up. Okay? Some of these other equations are what's called quadratic in form. If you can write it in the form au squared plus bu plus c equals 0, that's what we mean by quadratic in form. For example, this one's kind of rigged. We have x squared minus 1 squared plus x squared minus 1 minus 12 equals 0. I want to point out that this guy is quadratic in form. If you let u equal x squared minus 1, then what you have is u squared plus u minus 12, don't you?
Yeah.
In other words, u squared plus u minus 12 equals 0. And that doesn't look near as mean, ugly, and scary, does it? This is easy to factor. It factors in u plus 4 times u minus 3 equals 0. So u is negative 4, or u is 3. Yes?
Yeah.
But they didn't ask you what u was, they asked you what
X.
x. So what you have now is x squared minus 1 equals negative 4, or x squared minus 1 equals 3. Yes? And on this one, because it's just x squared minus 1, you don't have a b term in there, you can write this as x squared equals what? Negative 3, or x squared equals 4. Take square roots of both those guys. This gives you x equals plus and minus I times the square root of 3. This gives you x equals plus or minus 2. Yes?
Yeah.
Alright, now, notice that we get 4 solutions. Yes? Which we better get, because if you look at the original equation and think about it, that's really a 4th degree polynomial, which means you're going to have 4 solutions. They're not necessarily all real, they're not necessarily all distinct, but you're going to have 4 of them, right? In this case, we have 2 distinct real solutions, 2 and negative 2, and we have 2 complex solutions, I square root of 3 and negative I square root of 3. You with me? Okay, now, one of my issues with this unit is the title of this unit. The title of this unit is Higher Order Polynomial Equations. Yes? Okay? And then they give you problems like 5y to the 2/3 plus 33y to the 1/3 plus 18 equals 0. Which by nobody's imagination is a polynomial. Remember, polynomials have what? Nice exponents for, or nice numbers for exponents, yes?
Yeah.
When you start seeing exponents like 2/3 and 1/3, it's not a polynomial. You with me? Okay, but this thing is quadratic in form, and that's why they put them in this unit. They are quadratic in form. Okay, because if you can make a substitution, think about the variable part of your middle term, y to the 1/3 in this case. If I let u equal the variable part of my middle term, y to the 1/3, and then square that, u squared will be y to the 1/3, 20 squared, that gives you y to the 2/3, which voila, is the variable part of your first term, yes? This thing is quadratic in form. In other words, we have 5u squared plus 33u plus 18 equals 0. Yes? y to the 1/3, right? U squared is y to the 2/3. So this turns into 5u plus 33u plus 18. 5u squared plus 33u plus 18. Yes? All right? And that's not near as bad as that, is it?
No.
Okay? Let's try to factor that, or if you don't like factoring, you can throw in the quadratic formula. Most of these will factor. Okay? If we take 18 times 5 using the AC method, 8 times 5 is 40, 18 times 5 is 90.
90, 3 and 30.
So two factors of 90 that add to 33 are
3 and 30.
3 and 30. So I'm going to write this as 5u squared plus 30u plus 3u plus 18 equals 0. Factoring that by grouping, you can pull a 5u out from the first two, you get u plus 6. Pull a 3 from the second two, you get u plus 6. Now we have a common factor of u plus 6. So we have that. And that gives you solutions of u equals negative 6 or u equals negative 3/5. Yes? But you're not after u, you're after what?
1.
Y. So what you have is y to the 1/3 equals negative 6, or y to the 1/3 equals negative 3/5. Now how do you make that 1/3 jump go away? You raise both sides of the equation to the third power. We'll take this up to the third and take this up to the third. Y to the 1/3 raised to the third gives me y. Negative 6 to the third is negative 216. Okay? When I cube this, I get y. When I cube that, you get negative 27 over 125. Now with me? Okay? Making sense? All right. Questions? Quiet all of a sudden.
Can you go back to the step in between where you have 5, it's like,
Here and here?
no, the one right below that, from, yeah.
From here to here?
Yeah,
Okay. You have a common factor of u plus 6.
okay.
When you pull that out, there's the u plus 6, and then you have what? 5u plus 3.
It wouldn't be u plus 6 squared.
Nope. This is like if you had 5ua plus 3a. What's the common factor here? A. A times what? 5u plus 3. So if your a is u plus 6. Okay? All right. Now, the next example I have for you is a cubed minus 3a squared equals a minus 3. And that's, once again, we're going to do the same thing we we're just talking about right here. You don't have to make a substitution on this, but what you do have to do is get that thing equal to 0. Okay? Anytime you try to solve a polynomial, first thing you'll do is factor it. Don't factor it unless it's equal to 0. Okay? Go with me? So the first step here is to write this as a cubed minus 3a squared minus a plus 3 equals 0. Now this is a third degree polynomial, so we're looking for 3 solutions, yes? You have 4 terms, nothing common to all 4 terms. So the next thing you do is try grouping, right? Look at the first 2, you see any common factors?
A squared.
A squared. So we'll pull a squared out, and we'll get a minus 3. Now if this grouping thing's going to work, the back half has to turn into a minus 3. So I'm looking at negative a plus 3. What can I pull out that's going to give me a minus 3?
Negative 1.
Negative 1. Now I have a common factor of a minus 3 times a squared minus 1 equals 0. Yes? Now with me? Yeah. And you can factor a squared minus 1. That's the difference of squares, so we get a minus 3 times a minus 1 times a plus 1. Still equals 0. So that tells us that a is equal to 3, 1, or negative 1. Okay? Go with me?
Yeah.
All right. Now, third degree polynomial, 3 solutions. Yes? Okay? All right. Now, the last example in this unit. Well, no, it's not. Sorry, I got 2. 3x to the 11 thirds plus 2x to the 8 thirds minus 5x to the 5 thirds equals 0. And this is one of those that looks a whole lot harder than what it really is. If you understand the laws of exponents and how they work, this isn't that bad. First, do you see a common factor? X to the 5 thirds. So we're going to pull x to the 5 thirds out. Now what times x to the 5 thirds gives me 3x to the 11 thirds? Well, the coefficient's going to be 3. The tricky part here is the exponent, yes? Remember, we're adding and subtracting exponents right now, right? In other words, what plus 5 thirds gives you 11 thirds? 6 thirds. AKA 2. Yes? Okay? Same thing here. The numerical coefficient is still 2. The tricky part is the exponent on the x. Now what plus 5 thirds gives you 8 thirds? 1 or 3 over 3, yes? Okay? Minus 5 still equals 0. So we get x to the 5 thirds times 3x squared plus 2x minus 5 equals 0, don't we? Yes?
Can we do it again, please?
Alright. Looking at the start, you have a common factor of x to the 5 thirds, yes? So you pull it out. Now it's just x, so the 3, the 2, and the negative 5 are going to stay the same. Now, what times x to the 5 thirds gives you x to the 11 thirds? In other words, what plus 5 thirds gives you 11 over 3? 6 over 3. Yes?
Yeah.
6 over 3 is really what? 2.
Yeah.
Okay? What times x to the 5 thirds gives you x to the 8 thirds? In other words, 5 thirds plus what gives you 8 over 3? 3 over 3, or 1. Okay? All right, now, this tells us that x to the 5 thirds is equal to 0, or 3x squared plus 2x minus 5 equals 0. I think I forgot to point out that this equation is not a polynomial, right? Fractional exponent is not a polynomial. Go with me? Go with me here? Okay, now, x to the 5 thirds. Officially what we're doing is we're raising both sides of the equation to the 3/5 power. We're making the exponent x 1. But because this is 0, you can say that's 0. You can get by with that with 0, and you can get by with it with 1.
I don't get why you separated them.
Because I'm trying to find out what x is. And this tells me that since this is a factor, it's going to be equal to 0, or this guy's going to be equal to 0.
Okay, so it's 2 different parts.
Yes.
Okay.
Okay? It's just like back over here. Okay? We separated these two, didn't we? We said that u equals -6 or u equals -3/5. Okay? All right, so we got part of it done. Now, let's talk about 3x squared plus 2x minus 5. Okay? Generally, you can factor these. It would take 3 times -5, I get -15. 2 factors of 15 and subtract 2 are 5 and 3. So I can write this as 3x squared minus 3x plus 5x minus 5 equals 0. Factoring that by grouping, you pull a 3x out from the first two, gives you x minus 1. 5 from the second two, gives x minus 1 equals 0. So x minus 1 times 3x plus 5 equals 0. Yes? Are you with me? And basically, I separated this out so I didn't have to write x to the 5/3 of all these steps. Okay? This tells us that x can also be equal to what? 1 and negative 5/3. Okay? So, in this case, we get 3 solutions. Okay? Go with me? Alright? I have one more.
Why is it negative 5/3 if it's?
It should be 3x minus 5, shouldn't it? And then you get 5/3 for the answer. Because you factored out an x minus 1.
I factored out x minus 1, here's my x minus 1.
Okay, yeah, never mind.
Okay, what have I got left? 3x plus 5. Okay?
Why would, I don't see the x minus 1 wouldn't be negative 1?
I want to take x minus 1 equals 0,
Okay, that's
x is 1. So take 3x plus 5 equals 0, x is going to be negative 5/3. Okay? All right. I got one more for you today. And I don't particularly care for this type of problem, but you're going to have one in your homework. Y minus 6 to the negative 5 halves plus 7 and y minus 6 to the negative 3 halves equals 0. Okay? Now, first off, this is not a polynomial, right? We have ugly numbers for exponents. Second, you see y minus 6, and then the same thing, y minus 6, yes? Okay, so, because I've got y minus 6 and y minus 6, I'm going to handle this a little bit different than what you normally would. I'm going to write y minus 6 and negative 5 halves equals negative 7 times y minus 6 to the negative 3 halves. Add negative of this term to both sides. In other words, I'm just taking this across the equal sign. Go with me? Now, I have negative exponents, yes? I want to get rid of them. This turns into 1 over y minus 6 to the 5 halves power equals negative 7 over y minus 6 to the 3 halves power. Yes? With me? Okay, now, it's kind of like cross multiplication. Let's bring the negative 7 down here, let's take this up here. So we're going to get negative 1/7 equals y minus 6 to the 5 halves over y minus 6 to the 3 halves. Go with me there.
Where did you do exactly?
I brought this up here, brought the negative 7 down there. Just chose to write the negative on the top instead of the bottom. Okay, go with me? Go with me? All right, now, we have something over the same something to some power over some power. What do you do with these exponents? Subtract. What's 5 halves minus 3 halves? 3 over 3 or 1. So what this turns into is negative 1/7 equals y minus 6 to the first. Yes? y minus 6 to the first is simply y minus 6, isn't it? So now we can say, well, 6 minus 1/7 is equal to y. Yes? And what's 6 minus 1/7? Well, it's 5 and 6/7, right? Which is 35, 35 and 6 is 41. So, you with me? You with me here?
Can we go back to the step where you switch the numbers and then the step five?
Okay, here, here, okay? All right, so this y minus 6 right here comes from bringing this guy up here, okay? This y minus 6 to the 3/2 comes from this guy right here. This -7 goes down here, so this, when I take this up here, I get 1. And then I get 1 divided by -7 gives me -1/7. Okay? So, I have -1/7 equals this, yes? Now, I have the same thing over the same thing, you subtract the exponents, right? 5/2 minus 3/2, 2 over 2, which is 1. Okay? All right. Anything else? Any other questions?
How'd you get the 41/7?
7 times 5 is 35 plus 6.
Okay.
The denominator stays the same. And I don't care which one, they're both exact numbers. Are you with me? What you don't want to give me there is a decimal approximation. Okay?
Well, I'll have it. So when you have 6 minus 1/7 equals y, where did you get the 5 to the 6/7?
Well, 6, I'm thinking the 6 is 5 and 7/7.
I see that. And then when you subtract that, you're at,
Yeah, 7 minus 1 is 6, I guess 6/7. Okay?
I see
All right. Okay, so that's basically what I have to say about 2-4. Okay, so 2-3 and 2-4 are gonna be due Monday night.